Okay, last shape from Unit 10. It's a sphere. This is probably going to be the easiest. There are some different looking formulas. We're going to do surface area and volume in the same day because there is no lateral area. If you look at a sphere, there's no walls. Okay, everything's curved. You can't have lateral area and surface area. It's just surface area. How much can you touch on it? We'll look at a hemisphere as well and talk about how we'd have to adjust that. But a sphere is a three-dimensional set of points equidistant from the center. Okay? So every point you pick on the edge of the circle or the surface of the circle is the same distance away from the center. We call that the radius. Okay? The great circle goes around the hemisphere, cuts it in half, and that's what we're going to be looking at. So surface area is going to be 4 pi r squared. We're going to do a little activity in class. I'm going to show you how that comes about. Volume, you're just going to have to trust me on and trust the ancestors of this great subject. It's 4/3 pi r cubed. Okay? So it's easy to get them mixed up. Make sure you have pi r squared, pi r cubed down. That's for surface area versus volume. So if we look at this, pretty simple idea. Write down your formulas. So surface area is 4 pi r squared. Plug in 4 pi times the radius squared. So we have 11 squared, which is 121. Hopefully you know that one, times 4. Which gives us 484 meters squared. Volume, 4/3 pi r cubed, because it's three-dimensional. So that's 4/3 pi times the radius cubed, or the radius is 11 cubed. This is going to be a much bigger number. Make sure you do 11 to the third power on your calculator, which is 11, the caret symbol on the right, above the division sign, 11 to the third power. And then you can do times in parentheses 4/3 if you want, or you can do times 4, then divide by 3, either way. And you get a fraction. Can't have a fraction, so we're going to have to leave this number as math frac, 5,324 over 3 pi meters cubed. Given exact answer is what it says, so that's what we follow. Second one, 4 pi r squared. 4 pi times, careful, radius is 12 squared. So that would be 144 times 4, or 576 pi inches squared. It's surface area. How much can you touch on the surface of the ball or sphere? Volume is 4/3 pi radius cubed. So 4/3 pi times the radius is 12 cubed. So we're going to do 12, caret symbol, 3. Times 4/3, and this one actually works out nicely to 2,304 pi inches cubed. That's how much you could fit inside the ball. Okay, so nothing too tricky there. I'll look at this one, see if you guys can kind of think about it. Find the exact surface area and volume of the hemisphere. Okay, volume's not going to be as tricky. Surface area. A lot of you are probably thinking to yourself, okay, surface area of a hemisphere, I'm just going to take 4 pi r squared and divide it by 2, which is true. But if you think about it, your original sphere is this, and you can't see that inside. If you just cut it in half, that means you can only touch that outer bowl. You have to account for this top surface that you're going to now be able to touch. Think about if you take an orange, cut it open, you can now still touch the outside that you were originally able to touch, plus the inside. So our surface area formula for a hemisphere is going to be this. 4 pi r squared, and we're going to end up reducing this. 4 pi r squared divided by 2, which a lot of you would say, plus you have to add on that top circle, pi r squared. So what it reduces to is really 2 pi r squared plus pi r squared. If you wanted to further combine that, you could say, okay, that's just 3 pi r squared, because they have the same units everywhere. So that would be the surface area of a hemisphere right there. So we have 3 pi r squared, or 3 pi times the radius is 16 squared. So that's 256 times 3, 768 pi meters squared. Volume, okay, volume is not as tricky to think about. That's going to be 4/3 pi times the radius cubed, all divided by 2. because you are just cutting the volume in half. You're taking exactly half of it. It's a little bit different than surface area. You could reduce that if you wanted, or you could multiply by 1/2 and make it 4/6 or 2/3 pi r cubed instead of dividing the whole thing by 2. It comes out to be the same either way. So 4/3 pi times 16 cubed all over 2. So this is what I do on your calculator. Make sure you're practicing this stuff. Go grab it, pause this, and go get your calculator if you need to. So 16 to the third power, big number, 4,096. Then I'm going to do times 4/3 in parentheses, and I'm going to hit enter. And then I'm going to divide that all by 2. I know I have a decimal sitting there. Divide it all by 2. And I get another decimal. So I'm going to leave this as MathFrak 8,192 over 3 pi meters cubed. Not the prettiest looking answer, but that's how we keep it. 16 cubed times 4/3, all divided by 2. Okay? If you don't have MathFrak capability on your calculator, you're going to have to do top first, then bottom, and reduce as you go. Okay? A couple more we're going to look at. We'll see where I want to stop. I'm not sure. Depends how I'm feeling as we go through these. The diameter of a baseball is 3 inches. What is the surface area and the volume of the baseball? Okay? So let's do surface area first, which is 4 pi r squared. So that's going to be surface area is 4 pi times, if the diameter is 3 inches, the radius is 1.5. So that would be 1.5 squared times 4. So the surface area would be 9 pi inches squared. If I wanted to, let's see what 9 pi comes out to be. So the surface area of a baseball is approximate answer about 28.3 inches squared. So that's the surface area. Volume of a baseball, how much is inside that thing? 4/3 pi r cubed, or 4/3 pi times the radius, which is 1.5 cubed. So let's see what we get here. 1.5 to the third power times 4/3. We'll leave that as MathFrak. So we get 9/2 pi, and that's inches cubed. Let's see what that comes out to be approximately. So 9/2 pi is about 14.1 inches cubed that you could fit inside. Okay? So it's not uncommon for volume to be a little bit smaller, but again, inches squared and inches cubed are two totally different units there. I like this next problem a lot. Multi-step problem. We're going to look at this probably, and then maybe we'll do 5 and 6 tomorrow at the beginning of class. We'll see how this one goes. If you like gum, you might like this. The gumball machine shown is 7 feet tall with a globe that is 36 inches in diameter. What is the volume of the globe? Okay, so I don't really care about the height of this. Okay, that's extra information. All I want to figure out is the volume of the globe first. So volume of the globe is going to be 4/3 pi r cubed, or volume equals 4/3 pi. The radius is 18 since the diameter is 36. So 18 caret symbol to the third power times 4/3. Ooh, we actually get a nice number. Volume equals 7,776 pi, and that's feet cubed. That would be our normal volume. Okay, if I wanted to find out what that is multiplied pi out, that would be about 24,429.0, and that's feet cubed. Oh, nope, that's not feet. I was going to say, that'd be way too big. That'd be a huge gumball machine. Inches cubed I should have had. So there's our approximate volume. Okay, so all we did was multiply that number by pi. Now, if a gumball has a diameter of 1 inch, how many gumballs do you think will fit inside the machine? Okay, so if we have a total volume and we want to know how much could fit inside, and gumballs take up space, which means gumballs have a volume. We need to figure out the volume of the gumballs first. So let's figure out our volume of our gumballs by doing 4/3 pi r cubed, or 4/3 pi times, if the diameter is 1 inch, then our radius is 0.5 cubed. So 0.5 to the third power times 4/3. So we get about 1/6 pi after we do our math, frac, and all that. So 1/6 pi inches cubed, or let's see what that comes out to be with pi. About 0.5, we'll go 0.52 inches cubed as our volume for a gumball. So let's look at this. That's a huge gumball machine. We have a total volume of 24,429.0. Each gumball is 0.52 inches cubed. To find the number of gumballs, hopefully you guys are thinking this, number of gumballs, we're going to figure out by doing the total volume divided by our gumball volume, because how many can you divide it up into? So that's going to come out to be, let's see, total volume is 24,000. We're not going to use pi here because that's just going to make it complicated. 24,429 divided by 0.52, 429 divided by 0.52. Holy cow. You get 46,978.84615. Okay, how many can fit inside then? If it's 46,978.8, you would have to say that you can only put 46,978. You cannot round up to 9. You don't have space. That's plenty of gumballs already. So you can put that many gumballs into your machine. Okay, so that's a lot of gumballs. Now, one little step extra. The machine also comes with a smaller inner globe. I don't know if you guys know this. That has a diameter of 25 inches, so the machine looks fuller than it really is. So they kind of trick you so that it's not really as full. What is the volume of the remaining space of the large globe? Okay, so this is basically what we're looking at. This is what they do to you. They have the big globe, and then they have another smaller one in between. And here's your gumball machine. They have that smaller globe in between that takes up space. So we want to figure out, okay, what's that donut shape? Obviously, it's three-dimensional. It's hard to draw a sphere that's being cut there, but that's the idea. So we know the machine also comes with a smaller inner globe. So we want to figure out that inner globe. So we have the volume of the inner, which is going to still be 4/3 pi r cubed. So 4/3 pi times, that would be 12.5 cubed, because the inner has a diameter of 25 inches. So let's see, 12.5 cubed times 4/3, which is going to be some crazy number. So we have volume of the inner gets us 15,625 over 6 pi inches cubed. So the approximate volume of our inner, let's just go with approximate. That's what I'm choosing to do here. So that times pi, oops, made a mistake on my calculator. So 15,625 divided by 6 times pi. So we're going to get about 8123, we'll call it, inches cubed. So there's our volume of our inner. So we know the volume of our outer. We know the volume of our inner. We want to find that shaded region, if you will. So you're going to take the volume of your outer, the whole thing, minus the volume of your inner to get your volume you want. So if we look back, we had a volume of 24,429.0 minus 8,181.23. So our volume, let's do that, 24,429 minus 81.23, 8,181. Our total volume that actually is in there is 16,247.77 inches cubed, we'll call it. And that would be our total volume that's actually in there. I can make you figure out again how many gumballs would go in there. You could figure that out. But just to give you an idea of what we're doing there. Okay? We're going to save number 5 and 6 to run for class. A couple that I want to look at there. Rediscuss the whole hemisphere when you're trying to find surface area of a hemisphere thing. And number 6. You can always go through and work on these, but we will do these tomorrow at the beginning of class. See you guys.